Okay, welcome back here at the Learning Tutorials. So in today's video, we're going to, discuss one topic in our structural theory, which is degree of indeterminacy. So we're going to discuss the degree of indeterminacy for beams, frames, and truss. So structures can be classified according to the degree of static indeterminacy. So it could be statically indeterminate or indeterminate. So if it talks about determinate structures, meaning equilibrium equation is enough to analyze the structure, and if it talks about indeterminate structures, meaning equilibrium equation is not enough to analyze the structure. So we need help for compatibility equations. So it could be by stiffness or by deflection. So the degree of static indeterminacy is the number of redundant forces in the structure. So if we talk about the redundant forces, these are the forces that cannot be found by writing and solving only the equations of equilibrium. They must be independent. So thus the degree of static indeterminacy represents the difference between the number of static unknowns. So these are the reactions and internal forces. So the reaction, these are external reaction caused by the support, and internal forces, those are the member forces. No? We have the axial, shear, and moment. And the number of static equations, so those are equilibrium equations. So in general, I can be written as the number of unknowns minus the number of equations. So if the degree of indeterminacy is equal to 0, so means that it is statically determinate. And if it is less than 0, so that is unstable structure, and if it is greater than 0, so it means that is indeterminate. So we have two formulas in solving for the degree of indeterminacy. One is for external and the second one is for internal. So the difference between the two, external, the formula only contains R, no? So pertaining to the reactions, support reactions, and for the internal, you can say we have also the reactions in addition to the internal forces. No? So for every member, we have three unknowns, and those three unknowns, those are the axial, shear, and moment. Okay, so we have the axial, shear, and moment at every member M. So M stands for the number of members, R stands for the number of reactions, J stands for the number of joints. So here, this pertains to equilibrium equation. We have summation of forces X, forces Y, and moment about Z axis. So that's why it's 3, no? 3 times at each joint. Also, here in external indeterminacy, we have summation of forces X, forces Y, and moment about z-axis equal to 0. So we have three equilibrium equations. And EC stands for the conditional equations. So let's talk about conditional equations. Before that, it is considered unstable externally if the reaction is less than 3 plus AC, and it is considered determinate externally if R is equal to 3 plus AC, and it is considered as indeterminate externally if R is greater than 3 plus AC. And it is considered unstable internally if 3M plus R is less than 3G plus AC. It is considered as determinate internally if 3M plus R is less than 3G, is equal to 3G plus AC. And it is considered as indeterminate internally if 3m plus r is greater than 3g plus ec. Okay, so let's talk about the conditional equations. So conditional equations, these are the release condition within the structure that provide extra equilibrium equations beyond the three global equilibrium equation, which is summation of forces x, y, and z, moment at z-axis. So, for example, here in the internal hinge, so we have an extra equilibrium equation at internal hinge. We have summation of moment equal to 0. So that's why the number of conditional equations is 1. And for the internal roller, we have summation of forces, horizontal forces, and summation of moment at internal roller equal to 0. That's why we have uh, conditional number of conditional equation equals 2. So there are also other cases where internal glide is given. So in this case, summation of vertical forces is equal to 0. That's why we have conditional equation equals 1. Okay, so if the members is if the members connected to the internal hinge or roller is more than 2, so let's say 3, 4, 5, and so on, so we have a general equation in the determination for AC. No? So if it is internal hinge, AC is just n minus 1, and if it is internal roller, AC is just 2 times the quantity of n minus 1, where n is the number of members connected to the hinge or roller support. So for trusses, so we have that is a special case since uh, each member in a truss has a pin at each end. No? So in one member, we have uh, each end that is a pin support or a hinge support. So that is a special case. So the conditional equation for truss is we have 2m minus the uh, J, no? M stands for the number of members for the truss system, and G is the number of joints for the truss system. Okay, so if we substitute the formula for AC as one, substitute the formula in the internal indeterminacy. So we'll get 3m plus r minus 3j plus 2m minus j. No? So we simplify that, we have 3m plus r minus 2j plus 2m. No? And then we combine like terms, so we have 3m minus 2m plus r minus 2j. So, and then we have now the formula in solving for the degree of indeterminacy for the truss. We have m plus r minus 2j. Okay, so it is considered unstable internally if m plus r is less than 2j, and it is considered as determinate internally if m plus r is equal to 2j, and it is considered indeterminate internally if m plus r is greater than 2j. So all in all, so the general formula in solving for the degree indeterminacy is just the unknowns minus the equation. So mostly for beams, if you want to find out if it is indeterminate or determinate, we can use the formula I equals r minus 3 plus EC. And for frames, we have I equals 3r plus 3m minus 3j plus EC. And for trusses, we have r plus 1m minus 2j. So as you see here in the member, this one stands for the axial force. No? For a truss element, uh, meron lang siyang axial force na unknown. So it means uh, there is no shear and there is no moment. No? Theoretically, ganun yung assumption natin for truss. And the number of joints, so we have at every joint, so we can use summation of forces x equal to 0 and summation of forces y equal to 0. So for frames, so we can use at every joint, summation of forces x, forces y, and moment equal to 0. That's why it's 3 at every joint. And for every members, we have axial, shear, and moment. So we have also for beams, we have summation of forces x, forces y, and moment about z axis, we have 0. Okay, so in the next video, we're going to use the formulas here to determine if determinate or indeterminate. Indeterminate or unstable. So, okay, so let's solve. So we have a cantilever beam. So we just need to count for the number of reactions. So for fix, we have 3 reactions. So we have no conditional equation given since there is no internal roller and internal hinge. So we can now get the degree of indeterminacy. So that is r minus 3 plus EC. So we have r, we have 3, and 3 plus 0. So thus we have 3 minus 3, 0 degree. So meaning determinate. So how about the prop beam? So again, we have uh, 3 reactions at fix and 1 reaction at roller. So a total number of reactions is we have 3 for fix and 1 for roller. So we have 4. Conditional equation, so there is no internal roller and internal hinge. That's why EC is just equal to 1. So if we compute for the degree of indeterminacy, we have 3 plus EC. We just need to substitute the values. So we get 4 minus 3 plus EC. So we have 3 plus 0. So we have 4 minus 3. So we have 1 degree indeterminate. Okay, so how about a continuous prop beam? So again, we have 3 rotation, 3 support, 3 action at fix, 1 at roller. So the number of reactions we have 3 plus 1 and 1, so a total of 5 reactions. Uh, there is no internal hinge and internal roller, so we have 0. And we have I, that is R minus 3 plus EC, so we get 5 minus 3 plus EC. So we have 5 minus 3, so therefore we have 2 degree indeterminate. Okay, so what it means is we have determinate structure. So this is a cantilever beam, so that is uh, a determinate structure. So since we have the degree of indeterminacy, which is equivalent to 0, it means there are no redundant forces acting uh, on the structure. So it means that summation of forces x, summation of forces y, and moment along the z-axis is enough, or the equilibrium equation is enough to analyze the cantilever beam. So how about we have sa prop beam, we have 1 degree indeterminate. Means that we have uh, one redundant force. No? So we have one redundant force, and that is caused by a roller support. No? So imagine if you remove this roller support, you will have a cantilever beam. So it means due to roller support, so that's why it becomes indeterminate and and becomes more stable at the same time. No? So it means that summation of forces x or forces y and moment is not enough to analyze the prop beam. So we need a compatibility equation, it could be by deflection or stiffness, to analyze uh, the prop beam. Okay, so the number or the degree of indeterminacy that defines the number of redundant force. So again, if you just consider the cantilever beam and then you add the roller support, so that becomes indeterminate. So here we have two. So again, dahil yan sa mga roller support natin. No? So imagine if you remove this roller support, the beam would be cantilever beam. So at the same time, it makes the beam more stable. No? Okay, so on the other hand, we can also use this degree of indeterminacy to determine how many number of internal hinge that we need to be added in our structure to analyze it using the equilibrium equation. Okay, so for instance, I just need to add page. So let's say we want to analyze the prop beam uh, using equilibrium equation. So we need uh, one internal hinge. So if we add one internal hinge here, this is a hinge. So therefore, this becomes 1. So the AC will become, wait lang. So, copy ko na lang. Copy. And I just need to paste it here. So let's say we add internal hinge. So can convert this one into 1 and then we have 1. So a total of 4. So this becomes 0. So indeterminate. So we can also use the degree of indeterminacy to determine how many number of internal hinge to be added in the structure. So at least approximately analyze the structure. So ganun, no? So especially for frames, if you want to analyze frames, we add internal hinge. No? So that's another way to look up the the value for the degree of indeterminacy. So again, the degree of indeterminacy, eh, that represent the number of redundant force, and then it means to say uh, you have added additional uh, member or additional reaction, and that is also mean that if you want to analyze it using summation of forces x and y and z, moment at z, or equilibrium equation. So that's another one. That's one way to do it, no? By adding internal hinge. However, internal hinge is there's specific position kung saan mo pwedeng ilagay yung internal hinge. So most probably dun sa walang moment, no? Which is dun sa point of inflection. So if you just need to plot the point of inflection for this beam where moment is 0, or you just need to plot the moment diagram, so you can get the uh, you can have the uh, elastic curve. So the point of inflection would be doon mo din ilagay yung internal hinge since yung moment doon is 0. So may position din siya kung saan dapat nilalagay. Okay, so continue na lang tayo sa next mga problem. Okay, so let's continue in the next video.